Hello everyone, this is Dr. Mo Shiva, Professor of Electrical Engineering Department at California State University, Fullerton. Purpose of this video is to do another example for mesh analysis. I have done examples 1 and 2 already. If you have not seen those videos, please go ahead and check those videos first and then come back here for the third example. I'm assuming you're familiar with mesh analysis, and this is just a review example. However, just a quick review. To do mesh analysis, we assign mesh currents to the meshes in the same direction, commonly clockwise. Then we apply Kirchhoff's voltage law to each mesh, written as summation of voltage drops across the elements equal to 0, and we do that in the direction of the mesh current. If we have current sources, we use supermeshes. So in this example, we see we have two current sources, one between mesh 1 and 2 and one in mesh 3. As I described it in the second example, we combine the meshes, and by combining, we don't mean that we define a new mesh. We simply look at these two meshes at the same time using I1 and I2. We go around that loop, write the voltage equation, summation of voltage drops equal to 0 for the supermesh, and then we immediately look inside the supermesh. That gives us two equations. For the other current source, if we shade this, there is nothing on the right-hand side of it. There is no other mesh to combine with this. So current sources on the outer loop, they are extremely useful. If we look at that current source, it immediately tells us I3 is 1. So that really makes life easy. As I mentioned it in the previous examples, start on the lower left corner or any place that you like of the mesh and end Kirchhoff's voltage law at the same point. So let's start with the supermesh. Supermesh is a combination of meshes 1 and 2. Start at the lower left corner and let's go clockwise. We do that so we don't miss any of the elements. First, what we see there is a voltage source. We are entering its negative side. So pretty easy using voltage drop. Just change the sign of 12, negative 12. On the top, we have a 1 ohm resistor moving from left to right, 1I1. Next, we are going down through the 2 ohm resistor. So we have positive 2. Branch current going down. We find it from mesh currents. So that's I2 minus I3. And finally, at the bottom, 1 ohm resistor, current I2 equal to 0. Whenever we use a supermesh, immediately we look inside the supermesh. In other words, look at the current source inside. What is that providing to us? What is the information obtained from that? And that is telling us current going up in the direction of I2, opposite direction to I1 is 2Vx. Mesh 3, as I mentioned, current source on the outer loop. It just gives us the mesh current. It tells us I3 is 1. And finally, we have an extra unknown here, Vx. Let's find it. Vx is defined on the top right across the 1 ohm resistor. So that's equal to 1 times I3. Quickly check for a sign mistake for terms involving resistors. I have mentioned this in previous videos. Since we are using voltage drop, for Supermesh 1 and 2, we should get positive I1 or positive I1 minus something else, positive I2 or positive I2 minus something else meaning another current. So we don't have a sign mistake there. Vx is equal to I3 and I3 is equal to 1, so Vx is equal to 1. So if you substitute that right there, this equation becomes 2 times 1 equal to 2. So that reduces the problem to 2 equations in 2 unknowns, first and second equations. Simplifying, we have I1 plus 3I2 equal to 12 plus 2I3, in other words 14. Second equation, negative I1 plus I2 equal to 2. Add these 2 equations together. I1s cancel out. We get 4I2 equal to 16. So I2 is 4 amps. And from here, I1 is I2 minus 2 equal to 2 amps. So we have the 3 mesh currents. The problem is asking for power supplied by the sources. For power, as I have mentioned this in previous videos, we use passive sign convention. So if you have a current I and voltage V across a resistor, we say P is equal to VI, and that is not as simple as it looks. What we really mean is absorbed power is voltage times current entering positive terminal of V. So power really means absorbed power. If the absorbed power turns out to be negative 5 watts, that means the element is really not absorbing power, it's supplying 5 watts. If you want to look at supplied power directly, we better look at voltage times current exiting the positive terminal. So for 12-volt source, positive is on the top, negative is at the bottom. Current exiting the positive is I1. So for that, if you want to look at supplied power directly, power is that's for that source 12I1 equal to 12 times 2, 24 watts. Make sure you write the word supplied next to it. Otherwise, power generally refers to absorbed power. Let us look at the current source on the right hand side. For that, if we use V1 and multiply that by 1, that gives us the supplied power directly. And to find V1, we can look at third mesh. V1 is summation of voltage drops across the 2 ohm at the bottom, 2 ohm on the left, and 1 ohm on the top. So, power for the current source supplied power is 1 V1 supplied. What is V1? Voltage drop, Kirchhoff's voltage law, 2I3 plus 2I3 minus I2 plus I3 gives us negative 3. So we end up with 1 times negative 3, negative 3 watts supplied power. So in fact, this is equal to 3 watts absorbed. So the source is being charged in this case. The problem was asking for supplied power, so the answer is negative 3. For the dependent source, for supplied power, we need the voltage here. Let's call it V2. Then current is exiting the positive side, so V2 times 2Vx gives us the supplied power directly. Two Vx, that's the current, times V2, the voltage. So that's 2 times 1 times 1. And let's look at V2. V2, we can write it as voltage across these two elements. 1 ohm resistor plus 12 volts. So 1 ohm resistor, voltage of that would be negative 1I1. So for that, we get negative I1, add 12 to it, and we end up with 20 watts. Again, directly supplied power is calculated. Again, there were another 2 videos for mesh analysis. Please review those. And I have videos on other topics. I hope you enjoyed this video.